Welcome everybody, Sheldon here with Data Systems Architecture, and this is the second video in our series Advanced Concepts and Techniques for ClickHouse, where we're going to dive into some of the internals that are very important to understand as you're designing the schema for your tables, as well as the topology of your ClickHouse cluster. So ClickHouse is a horizontally scalable database, which means that you can replicate data on multiple nodes in a cluster, but also the data for a single table can be split apart. And part of the data can live on one node and part of the data can live on another node. And in the next video, we'll go over some storage options where in fact, all of the data can actually live off of the cluster itself and in an external data store. So it's important that we understand the architecture to see the pros and cons of the decisions we're making when we design the topology of our cluster as well as our schemas. So the database is optimized for read performance. And what this means in practicality is that every time you insert records into a table, there will be a lot of thrash on the disk and memory and CPU to reorganize that data to facilitate high performance read queries. And so you do not want to frequently insert records into ClickHouse. You want to batch your records. Your inserts need to be batched. And the general rule, as I mentioned in the previous video, is about one insert operation per second across your entire cluster in ClickHouse. Of course, that can vary quite a bit depending on everything, but that's a general good starting point. And so we're going to dive into the actual details of why we can't be just streaming one row at a time into ClickHouse. The first component in the data architecture is a part, and parts are not identical between nodes. This is a fundamental storage structure, a collection of data, and this can actually be different from one node to another. And this is why the query results can, from time to time, vary from one node to another. Each part actually maintains an internal index of the data that it contains so that the query engine can kind of optimize and find exactly which rows it needs, which parts it needs to execute a query based on the selectors that you've used in your queries and the filters. Additionally, there are granules and marks, and the index on the part creates an entry for each granule, the granule being by default 8,192 rows at the time of this video recording. And these columns are compressed and stored as arrays internally. And this compressed data is then referenced by marks so that the query engine it finds the right part, and then it finds the right granule using the index for that part. And then the marks point to the correct compressed array data for the data in your query. And this is how things work. And this creating these parts, managing the granules and the marks and the indexes, all of this stuff, it requires a lot of computational overhead that's happening as you insert rows. This process is called merging. So as you add rows, your parts get consolidated and rebuilt. And this merging process is one of the main things that you have to monitor in ClickHouse. An interesting thing, like an interesting quirk of ClickHouse, is that if you have records that you are not working with frequently, or you have data, let's say you have data organized by timestamp as your primary key or as your order by statement, you have a timestamp for time series data, and you never insert new records for data from like a year ago, and you happen to have some data that is like out of sync between replicas for that time range, it may remain out of sync perpetually, absent some kind of manual intervention with a query that forces the merge. So unless the writing engine is forcing a merge on a particular set of data, it can actually remain out of sync absent manual intervention. Additionally, because all of this is oriented around organizing the data on disk, updates and upsert statements are problematic in ClickHouse. There are techniques, to have an entire video on how to work with update and inserts and deduplicating records, but it requires more sophisticated query logic when you query the data, as well as more sophisticated data pipelines when you write the data. And so this is a major consideration for your schema design and the techniques you use for your ingress. And we'll dive into that more in a different video. So it's the managing the merges can be the limiting factor for scaling your cluster. If you end up with too many merges happening all the time and all your compute resources are going to merges, then your read queries are going to be delayed. And this is like something that you have to consider in advance. And of course, with relatively small data sets, if everything fits in a memory or everything fits on a disk on a single node for your table, then maybe this isn't going to be a major consideration for you, and the merges are never going to have any problems. But as you scale up and add more data, get into replication or perhaps sharding, this is all things that you have to test and work through your project. So the last thing we'll discuss is sharding, and I want to mention that sharding is oftentimes not supported by cloud providers who host ClickHouse, or you have to consult them independently. And sharding is like a very specialized and sort of rarely used technique in ClickHouse, as opposed to like Elasticsearch, where sharding is just sort of there by default. This is where large tables get split across multiple nodes, and you will of course have to use the distributed table engines, and you will have to use on disk or on node disks to handle the storage of your data. So you can't use the object storage, connecting you writing your ClickHouse data at S3 or whatever. That won't work. And that's honestly, if you're going to get into sharding, then you probably need to hire a consultant and start thinking about that right away if you really think you have that much data. So that kind of sums everything up on the fundamentals of the architecture. And now we're going to talk about some of the storage options in the next video.